Hello everyone. So now let's execute the code. First, let's take a look at the output and then I'll come to code. How many elements are there? There are four elements. The elements are 3, 4, 5 and 4. The maximum number of splitting operations allowed are 3. Okay, so let's take a look or focus on the end result for once. So minimum penalty for now, minimum penalty is 3. So original array was 3, 4, 5, 4. In sorted order it is 3, 4, 4, 5. Now to add 3 to our final result, we can add 3 as it is because 3 is less than equal to the penalty. 4 is greater than the penalty, so we'll have to split 4 into 3 and 1. Again 4 is greater than the penalty, split it into 3 and 1. 5 is greater than the penalty 3, so split it into 3 and 2. So this is the final array that you get when the minimum penalty is 3. Now let's take a look at the code. Let's take a look at the detailed output first, then we'll go to code. So we ask the user how many elements are there and then we entered the elements. Three splitting operations are allowed as user said. The first step that we did was we sorted the array. Now sorting the array, the one major purpose is to find the maximum element of the array so that we can find the range. So the range is 1 to 5. 1 is by default the lowest in any case and the highest will be the maximum number within the array. So maximum number here is 5. So 5. Now here we begin with our search. Okay, so binary search iteration 0 begins. Least penalty is 1, highest penalty is 5. Okay, we have already seen this working in the previous video, so I hope you can relate it with the output that you see here. So 1 and 5, we are searching between 1 and 5. The midpoint of our search space is 3. So will it be possible to have 3 as a penalty? For that we have a separate method which will check the number of operations required. So we are now inside the method that will check whether we can have 3 as a penalty. We are checking every element of the array starting from the largest. So considering the element 5, the total number of operations needed to split 5 so that the penalty is 3 is 1. One split will be required. You will split 5 into 3 and 2. Considering the element 4, total number of operations needed to split 4 so that the penalty is 3 is 1. Okay. So considering the element 4 again, it will be 1. That is you split 4 into 3 and 1. Only one split needed. And you can consider the element 3 as it is. So the element 3 is less than or equal to the penalty 3. So we know there is no need to split 3. So we have considered all the 4 elements of the array. The array is over. So now total operations needed so that the penalty is 3 is 3. 1 plus 1 plus 1. Total number of operations needed is 3. Since total number of operations needed do not exceed the maximum operations allowed, that is 3, penalty equal to mid is possible. Okay, it is possible to have penalty equal to mid, but it is possible, but can we do better? So searching for possibilities in the lower half of our initial search space. Lower half, low, that is the least value remains the same, that is 1. Highest value is updated to 3. So least penalty 1, highest penalty 3. We want to explore all possible values between 1 and 3. The midpoint is 1 plus 3 divided by 2, which is 2. So will it be possible to have 2 as a penalty? Again we'll count. So for 5, if we want to split 5 such that minimum penalty is 2, as we have already seen in the previous video, we'll have to split 5 into 3 and 2, and then we'll have to split 3 into 2 and 1. So 2 splits will be needed. For element 4, we'll need 1 split. For element 4 again 1 split. For element 3, 1 split. So total, that is 2 and 1. You divide 3 to 2 and 1 split. So total number of splits needed is 2 plus 3, that is 5. So since total number of operations needed 5 exceed the max operations allowed, that is 3, penalty equal to mid equal to 2 is not possible. It is not possible to have 2 or lesser as a penalty, but can we do better? can we search in the upper half of our initial search space. That is initial search space. Now for at this point initial search space becomes 1 and 3. So within the search space of 1 and 3, can we search within the search space 2 and 3? Okay, but we have to increment 2 to 3. So low becomes 3, which equals or exceeds high, which is 3. So binary search ends here, and we are returning the result being 3. So minimum penalty is 3. Now the right way to split the array is you sub um, if it is less than or equal to the if any element of the array is less than equal to minimum penalty, you carry it as it is into the result. So 3 less than equal to 3, carry it into the result or add it to the result as it is. 4 is greater than 3, so you'll have to split it and add it. 4 is greater, so you'll have to split it. 5 is greater, so you'll have to split it. Okay, so now let's take another example of 9. Okay, and now I'll just run the example. I don't think explanation will be needed here. So let's say there is only one element is 9, and maximum splits allowed are 2. Okay, so the final answer that we get is 333. Let's say there is only one element allowed. There is only one element in the array, 8, and maximum splits allowed are 2. Okay, so you get 332. Now let's take a look at the code. Okay, so starting from main, in main we first ask for the number of elements, we create the array, we ask number of operations, then we call find penalty dot minimum penalty. Now find penalty is the class, minimum penalty is the method within the class. It is static, so we can call it directly using class name dot method name. Okay, so now what do we pass here? We pass the array and we pass the maximum number of operations. Okay, so we pass, you see when we are calling it, we pass arguments a, which gets copied into the parameter a, and we pass maximum number of operations, which gets passed there into the parameter max operations. Okay, so now firstly we sort it, then we begin with binary search. So while low less than high is the criteria for binary search, now I'm maintaining an iteration count just to make the code good looking, or just to add these meaningful messages, just to make the output more readable and understandable for you. I added all these things, but this code can be written in, let's say, 50 to 60 lines of code at the most, or so. But the way I have written this, it just makes the output easy to understand. So iter count is just to keep a track of how many iterations of binary search we have completed already. So least penalty is low, highest penalty can be high. So this is just to make the output self-explanatory. This is basically binary search. Now inside binary search, when we want to check whether mid can be a penalty, we pass the array, the maximum operations, and mid to another function called is possible. Okay, so public static boolean is possible, because we are calling is possible from within a static method called minimum penalty. Is possible should also be static. So now inside is possible, our only aim is to count the total number of operations. So let's say the total number of operations will finally be stored in the variable count. Okay, starting from the largest element, if number is less than equal to mid, no problem, you can directly say that it is possible. If or otherwise, say number is less than equal to mid, you simply display that no splits will be needed, and you simply break the loop and go to the next element of the array. In case num is greater than mid, this is the formula. The number of operations, there are two cases. If the element of the array can be evenly divided by the number of splits, sorry, if the element of the array can be evenly divided by the penalty value, then that is mid. If mid evenly divides nums I, the number of splits needed would be nums I divided by mid minus 1. However, if it does not evenly divide, then we'll need one more split. So for example, let's say the element is 5, okay, and the possible split, that is mid, is equal to 2. In this case, 2 does not evenly divide 5. So firstly, the formula is num integer divided by 2 minus 1. So 5 divided by 2 is 2.5 real number. Integer division result is 2 minus 1. Answer is 1. Right? Whereas if it would have been something like 4, the element is 4 and mid is 2. What I'm trying to say here is one split will not be sufficient here. One split will only give you 3 and 2. So you will have to add one more over here. Okay, you'll have to split 3 into 2 and 1 to get the answer. Whereas in case of 4 and mid is 2, if the number is 4, element is 4 and mid is 2, 4 can be evenly divided by 2. So if we apply the formula 4 divided by 2 minus 1, it will be 2 minus 1 and this will be equal to 1. Okay, so 4 can be divided into 2 and 2. Minimum penalty becomes 2 right away. Are you getting it? So if the number is evenly, if the number is not evenly divisible by the proposed penalty value, we'll have to have number divided by 2 minus 1 plus one more split. Whereas if the number is evenly divisible by the mid, we can have number divided by the proposed penalty minus 1 as the number of splits. Okay, so accordingly we calculate the number of operations for each element. So this loop calculates the number of operations required for each element and we are updating our count value accordingly. Finally, our count will contain total number of operations needed. So total number of operations, if it is less than max operations, you allow it or you will return true, it is possible. Otherwise, you will return false, it is not possible. So I hope the code was clear to you. If you have any questions, any doubts, you can ask in the comments. And here you can see the last final simple step just to show the right way to split the array. Okay, what we do is we create an array list and for every element of the array, if it is less than equal to min penalty, we add it into the list directly. Otherwise, if the element which we store in temp here, so if the element is greater than min penalty, we subtract min penalty from the element and we add min penalty. Now this is a small trick just to keep the code easy. So basically if I'm adding 5, 5 minus 3 is 2, but 2 will not be added. 3 will be added first and then temp will become 2. So ultimately temp, that is 2, will be added. This is useful. Why? Because in case let's say the answer was minimum penalty is 2 and the element is 5. So we'll add 5 minus 2. If we add 5 minus 2, that is 3 first, then we'll have to remove that 3 and replace it with the values of 2 and 1, which becomes a bit clumsy. So rather what we do is we do 5 minus 2 in case, assume hypothetically that minimum penalty was 2 and the element was 5. So we add 2 to the list, then again we add 2 to the list and the temp that remains is 1. So 2 to 1 get added to the list. Okay, this is a trivial part just to you can do it any other way if you want. Okay, Ultimately, the important point of this program is to get the minimum penalty value right. Okay. If you have any questions, any doubts, you can ask in the comments. Thank you.